Over to you.
All right, thank you so much, Linda. Good afternoon, everyone. Yeah, happy to have so many participants here into this webinar. I hope all of you can see the screen and you can hear and see me clearly. As Linda said, I'm Adrian, and I'm happy to give you the start into this presentation, and later on, Serhii will take over for the service business. All right, so we would like to give you an introduction today on how services and digitalization can really help to improve your maintenance efficiency. And therefore, we have a kind of agenda. So the first topic will be master data of instruments and the so-called dynamic install base analysis. I will go, of course, more into detail there. The second topic will be covered by Serhii, is going into criticality assessments and how does this influence your maintenance strategy. Third topic is about calibration management and services in life science, also in comparison with a verification. And last but not least, I will take over again to give you an introduction on an example for a digitalization journey you can go as a life science producer. And then, of course, we have Q&A. As Linda already said, you can write it in the chat. We monitor it. And of course, in the end, we will also answer all these questions. But let's go into the topic. So what are the current hurdles in maintenance processes, right? So you see here on the picture in the scheme, let me quickly show the laser pointer, right? There is a plant shutdown, for example, right? That happens, it could happen from time to time, but then the question is how fast can you react so your plant is running again? And normally, or currently, it's a lot of on-site services, right? You go into the field, check what's wrong, go back, try to find the solution, maybe need spare part, maybe need to call your service provider or whatever, right? And the biggest issues you have is that there are lack of historical diagnostic information, right? You have missing inventory management information and also inaccessible data, right? But the data, they are already there. They are in the field, they are in the instruments, they are maybe in a higher level of digitalization, for example, but it's a challenge to get them, right? And based on these data, you can unlock data in data silos, right? You can really have or make decisions based on insights and analysis and not on gut feeling. And you have a complete view end-to-end what is happening in my plant. And this is actually where we want to go for. If you have a look on your asset management strategy, right? The challenge is here to find the optimum. You see here two graphics, right? On the left side, you see the triangle of asset management. So it's not only about reduce costs and mitigate risk. There's also a third factor which looks into improved performance, right? And this triangle needs to be in a balance because if you reduce the costs too much, maybe you do not have the right tools, or maybe you have less service technician on site, which maybe help you to mitigate the risk. So you need to find the balance here. And this is actually what it's shown here on the right side, that no maintenance is also a lot of cost, right? Too much maintenance is a lot of cost. So the challenge is really to find the optimum here, that the maintenance is on the best, let's say, level in comparison or in relation from total cost to degree of preventive maintenance. So what helps for that, right? So imagine you have thousands of assets in there, and the question is always, okay, what do I know about these assets, right? What happens when they fail, when they have an issue? So what kind of information do I have? And here actually master data come into place, right? And the master data means what is the device, from which manufacturer, can I see the cause and remedy information? Do I have the manual there? Do I have knowledge there? Do I have a calibration certificate? All these kind of things are master data, right? And to have them available at the right time is very helpful and can improve your maintenance efficiency. And you see here the different stages you can do maintenance, right? Reactive, break and fix. Something is wrong, I fix it, very reactive. But you can also go preventive. That means you have a schedule based. You say, okay, every 2 weeks, every 3 weeks, I have a check on that asset, right? But this is, of course, better and better. But we want to go into the direction of condition-based and predictive. That means condition-based is really focusing and monitoring the health of the instruments, right? And then when there is something wrong, we will fix it. And of course, predictive is our ultimate goal, where we're also working on that we can predict when something will happen, so you can act in the beginning, right? And all of these things, especially condition-based and predictive, without master data, not possible for you to do, right? So you need to have the base of what you have in your plant, so you can even think about going into condition-based or predictive maintenance. And that's the main point here I would like to show in this slide. So how is that possible? So master data is, what do I have in my plant? How many different manufacturers, how many different assets, how old they are, what is, let's say, all the documentation there. And currently, most likely you have it in papers and in folders and some cabinets, and no one will ever see that, right? And you cannot use the data and analyze it because it's spread all over your offices and all over your factory. So the goal of such a dynamic installed base analysis is to digitalize it, right? That you have digitally available what is in my plant. And based on that information, you can get recommendations, or you can make your own analysis on how can I improve the risk in my plant so I do not have a shutdown, right? So maybe old devices, maybe many different manufacturers, instead of standardizing assets. So these are all kind of things you can do when you have it in a smart way and have an overview of that. So to summarize that in a very simple slide, right? So the driver is reliability of such a master data and digital installed base analysis. And of course, the motivation is to reduce cost. So the idea is that there's a possibility to gather all the data, digitalize them, and give consultancy approach to you as an end customer to, let's say, have a look into your plant and give you recommendations on what and where you can improve. And the benefits are, of course, to mitigate risks and to prevent and give, for example, spare part stocks or standardized devices. And then, of course, also for a better price or whatever. So it's really, with this digitalization, you can increase your reliability already before you're thinking of having a calibration service or having anything else. Just looking at the master data on your installed base, what do I have? You can already save time, costs, and improve your maintenance efficiency if you have it digital. And saying that, I would like to hand over to Serhii now, which is taking now over on the part on criticality assessment and how does this influence your maintenance strategy. Serhii.
Thank you, Adrian. Adrian, you mentioned in the beginning of your presentation an important aspect. We want to optimize, meaning that we want to find the right amount of maintenance that is not too low and not too high. Because it's not only about the costs, actually. Yes, having too little of maintenance would increase the risk of the instrument failure, but having too much of maintenance operations in the field, meaning that you access the instrument, you touch the instrument, you perform various operations, and every approach to the instrument may bring some elements of risks as well. So it is very important, both from the risk point of view, risk management point of view, as well as from the cost management point of view, to optimize our calibration activities. Adrian, I would like to ask you to flip through my slides so it will be faster. Thank you. Here in this slide, I mentioned calibration activities, but calibration is a part of maintenance, an important one. It is so important that sometimes it is treated separately from the rest of maintenance tasks in terms of processes, tools, and even the teams of specialists may be different, those who do the maintenance and those who do the calibration. But nevertheless, both maintenance and calibration are required to keep the instruments performing in the best possible way. And thus, the optimization of maintenance and calibration have many common points. Here are 3 steps in this slide to achieve the most optimum calibration program, for example. The first of them is to define the criticality and to set the limits, as we call it, maximum permissible error. Then we go into the measurement performance analysis. And this last one is we optimize the calibration intervals. I will touch on the last point in a moment, but I would like to begin with the criticality assessment. This is indeed the first step as we go along with our partners, our customers, when we move from the execution of the existing maintenance program to developing some new, more optimum, the better calibration and maintenance program for our customers. Next slide, please. As you just saw, the first step was criticality, and why it is so. By assessing the criticality of assets, and by the way, by assets here, usually we mean instrumentation. But in the discussion of criticality and maintainability, the meaning of the word asset can be expanded to include other units, other devices, such as pumps and valves. Criticality is also important for them. Why it is important? Because, say, for instruments, you cannot set the correct values of the maximum permissible errors or the tolerances of your measurement points if you don't know how critical this measurement point is for your process or for your plant. Now, if you don't set up the maximum possible tolerances or maximum possible errors, then it would be difficult to assess what would be the right calibration interval, because taking a calibration interval in a fixed way just based on the manufacturer's recommendation is, of course, one way, but is it the most optimal way? That's a big question. Probably not. We'll come to this later. All of that, in the end, come to your calibration procedure, which is a part of your larger maintenance procedure. So you see, the initial point is the criticality assessment, and that's why we would like to discuss a little bit more how it is done and what it means. It directly impacts calibration and maintenance quality, the cost, and it forms the foundation for all of your maintenance program. Next slide, please. The importance of criticality is actually recognized as an important step in various processes. This, for example, is an adopted version from the GAMP that I took and simplified just to put it in one slide of the presentation. You may see that it's actually a part of the standard risk assessment in the life science industry. Identify criticality of the instrument is one of the blocks there. And then it goes, as I explained before, into the required intervals of calibration, and then it goes further in the loop to when we review the measurement capability of the instrument loops, and importantly, it goes into the selection process whether the instrument is suitable for the process at all. It may be in the beginning when you just at the qualification phase, in the IQ phase, when you decide whether the instrument is the right one for your process or not. But it may be also repeated periodically to see whether the existing instrument is still useful, it's still suitable for the process. Or if not, then there are reassessments which are needed. In one case, you may want to extend tolerances, reassess them. Can you extend the tolerances? But more often than not, you need to either to fix the instrument or replace it. So it's a known fact that criticality has to be there. You see, in the blue box that I put there, that area is covering exactly the part when we work with our customers together, and we support them in going through the installed base, as Adrian just mentioned before, extracting the master data, analyzing the existing data, and then together with the criticality and maintainability assessment, it forms the data which in the end leads to the selection of the right optimal maintenance and calibration program for our partners, for our customers, for their processes. Next slide, please. So what is criticality? The standard definition in metrological way is a parameter or indicating the consequences of a measurement deviation. Why I said in the metrological way, criticality can be different. It can be directly involving the risk assessment. For example, if the critical instrument fails, it may lead to a very dangerous effect or dangerous event in the plant. That's also an important aspect of the criticality. We look at the consequences. Can you, Adrian, please click twice so all of the slide will be there? Thank you. What impact would be a wrong measurement value having on the process? Are there any factors that mitigate these consequences? That's one aspect. What would be the consequence of the wrong measurement? Second, what is the probability of that event? How likely it is occurring? And are there any factors that would mitigate this probability? The third aspect which comes to the criticality is maintainability. How easily I can assess and handle my measuring device, how quickly I restore my device's accuracy. So altogether, it goes in the criticality definition. Now, the criticality definition is not set once and for all the customers, for all the industries. They should be really very specific and developed specifically for each process, for each plant, for each production. And that is why it is when we say to the customer that let's discuss on the criticality, we cannot give once and for all and universal method of deciding what is the criticality. We really need to talk and to see what is the production, what is the plant, how many instruments there are, what kind of instrumentation is there, and then select the criticality. Next slide, please. If criticality is assessed properly, then it would enable us to prioritize. Metrological criticality enables to do the prioritization, which measuring devices are important to monitor and maintain, considering the severity of a measurement error on several factors, such as health and safety, of course, how dangerous it is for people if the device, for example, fails. What is the financial effect? What is the environmental effect? And last but not least, what are the legal consequences if the device is not compliant? All of that are also factors which we take when we assess the criticality of the instrumentation. So you see, criticality is not something that is uniquely defined and for all, as I said, but there are some specific examples which we'll see at the next slide. As I said, criticality mainly has two factors in that. One is the severity. How serious will be the problem if the device fails or it goes out of the compliance? The other is probability of such an event. How probable it is that this event can occur? Mathematically, it's a multiplication operation which goes, if you want to assess it in numerical term, what is the criticality? You have to multiply these two factors, severity and probability. As I said already twice, probably, we can't give a universal example or a universal table for the criticality definition, but here on the left-hand side of this slide, there are some examples of high criticality, or medium criticality, and of the low criticality. As a rule of the thumb, high criticality in general means that if an event happens, say a failure happens, that your production will stop, or it can become dangerous for the production or for the people. On the other hand, on the other side of that scale, low criticality means that if the devices fail, there will be no major consequences. The production can be, for example, going on. If that device can be just for monitoring, it can be replaced, and but the production will not stop. Or the production can be going temporarily from automatic mode to a manual mode until the device is replaced. And medium criticality is something in between. But as I said, no universal recipe for the criticality. It depends on the local regulation. It depends on the internal rule of the production. So it's each time we assess it individually. What happens in the next step after we decide the criticality of the assets? We match them with the maintainability of these assets. Maintainability is, if we use the formal definition, it is an ability of an item under given condition of use to be maintained at or to be restored to a state in which it performs a required function. So, in other words, maintainability, to put it simple, just how easy is it to maintain this instrument? And by maintaining the instrument, I mean that to keep it in the state where it should work as it was supposed to. That is the more loose definition of maintainability, how easy it is to keep this asset, to keep this instrument in the state in which it's supposed to work. Again, maintainability can be quantified. When we quantify the maintainability, we again use several factors, and then we combine them together in a kind of addition or multiplication, if you want. One of them is obsolescence. Obsolescence means whether the device is still available if you want to replace it, or it is so old that you need to be replaced to a new model with all the consequences. Second factor is accessibility of that device for the physical maintenance. The device can be installed in such a way that it's either difficult to physically access it. For example, it can be in a skid in such a dense, packed in such a dense way that it's difficult to access it, or located at some height, or it can be just, yeah, in one of these situations, or accessing it would require some risk going to the site, for example. And the third factor is maintenance effectiveness, meaning that you have spare devices, you have skills, you have resources, you have technical support from the manufacturer, and last but not least, you also have a proper documentation database, which again was mentioned before by Adrian. If you have a master data in order, that means that you have all the documentations, all the reports, all the manuals reflecting the history of that device or asset in order. That, in that case, your maintainability becomes higher. If you don't have that, your maintainability becomes lower. When we mathematically evaluate the criticality and maintainability of all the assets, we make a matrix, which is shown on the left side of the screen. This matrix matches criticality and maintainability in such a way that color-wise, if you have a red color, it would usually indicate that this asset requires immediate action. Then if the color is getting cooler, that means that the further it goes into the cool side, the cool color, meaning that this priority of any maintenance action is lower for those kind of assets. And that that allows you, or it allows us together to make a program of maintenance which is optimal, meaning that we do not spend as much time as for all the equal time for all of your assets without considering each individual asset's need to be maintained. We put a priority there. We make a schedule in accordance to this colored scheme and with accordance with more quantified evaluation of the need of the maintenance. Now, coming to the next topic, as I mentioned, calibration is one of the important points there. And in the next discussion, I would like to discuss how do we calibrate and what will help us to calibrate in the more efficient way. This bath tube curve is very well known, and it was already shown once in the beginning of today's presentation. It shows that we try to find the degree of maintenance, which is the right from the cost point of view and from the risk management point of view. Not too little, not too much. It's the same for maintenance, it's the same for the calibration. Now, when it comes to the calibration, it comes to the calibration interval, of course. The more frequently you calibrate, the higher the costs. If you don't calibrate frequently enough, then you run into the problem, for example, of the product quality or legal compliance. So where is the optimal point? It comes to the decision how often you calibrate. So now the question for you, if you have a calibration program in your production facility, if you are familiar with people who are calibrating your devices, and I hope you do, then my question to you is that how often do you calibrate? Do you calibrate on a fixed intervals, or you reconsider those intervals? Here is the poll for you. Pick up one answer from these possible answers. There are 7 of them. So you see, it may be a fixed interval, which is set once and forever. It can be a fixed interval, which is periodically reviewed. It can be a flexible interval based on some considerations. And well, if you don't know, just would you like, if you would kindly just click on the I don't know part and submit it. I'll give you 30 seconds to do that. Don't be shy, please. Yeah, so while you're answering the poll, I can say that, except that for the I don't know part, all of these options are valid. Different productions have different rules and regulations when it comes to the calibration interval, right? So I'll just try to submit my answer as well and then go on. Could you please, Adrian, go to the next slide? Yeah, here is the result of the poll that I can see. Most of the answers, the top answer is fixed intervals, which are depending on the type of the instrument and so on. Yeah, so the fixed interval in, especially in life science industry, is the normal procedure. The second most popular answer is the fixed intervals, which are periodically reviewed. And I'm really happy that we have 26% of the respondents who have that in their facilities. That there is a process to review the intervals. While they are fixed, they are not fixed forever. And actually, none of the regulations stipulate, I mean, worldwide regulations like ISO, like FDA, and so on, none of them stipulate that they have to be fixed forever. On the contrary, it is recommended to periodically review them. Some of our customers have them reviewed on a regular basis. Some of them are dynamically reviewed. So meaning that it is not only a result of the past calibration that affects the further interval. It's the result of the all the history of the devices, not only the metrological history, but also the property of the devices, which affect the calibration interval. And we, on our site, when we work with the customer, we recommend going to from a typical calibration site, which is fixed. Next slide, please, Adrian. Like this one. So you see here that it's a typical calibration cycle, 6 months, you have a fixed interval. After 6 months, you recalibrate, and then your risk is more or less constant, but it's pretty high. We recommend to reduce risk or using the flexible calibration intervals, which are based on the data. And again, it's a part of the master data. It's a part of the data coming from the instrumentation. I will not stop of the details, but on the next slide, there are just examples illustrating how they are set. There are two methods. One is when the calibration interval is calculated based on the data coming from the last calibration result. The second one is more complicated when the data is taken from the several past calibration points, but both of them are methods which are based on metrics, and these are actually methods which were developed and patented for our company. We recommend them for the customer. There is software which runs and calculates the calibration intervals. So what happens if we compare these flexible calibration intervals with those which are already the customers are using now if they're fixed? Next slide, please. We find out, and this is an average of the findings that we found globally, that actually 2/3 of the devices are calibrated at approximately right interval, which is good. So we are right there, we're on the right track. Nevertheless, some 20% of the instruments are set up with the optimal, 20% of the instruments are calibrating with the optimal intervals. But 2/3 of the calibration intervals can be extended. So in the 2/3 of the cases, calibration interval is shorter than it can be from the optimal mathematical point of view. So if we move from the fixed calibration interval to a more periodically reviewed dynamic calibration intervals, then the average result is approximately 46% of less time operating out of tolerance compared to a fixed interval, fixed calibration interval approach. So 46% of the time, the device would be operating out of tolerance if we apply the correct methodology for the calibration interval. Next slide, please. One way to do that is to use the preventive-predictive approach to this cycle. We set up the calibration interval, we periodically review the intervals, we agree on them, we adopt them in the system, and that is during the implementation project. Now, when it comes to the operation, after calibration is done, the interval, the optimal interval, is automatically recalculated, and then it is reviewed with us and with the customer and with the production, whether we can extend it or shorten it, or it should be like that as it is now. And this is a repeatable cycle in order to reduce the risk and reduce the cost. Now, this is, of course, a theory. In practical, in life science industry, it's not so easy to review that often calibration interval. So there is another approach that helps us to reduce the risk and improve the efficiency. It is when we combine calibration at more or less fixed intervals with the instrument verification. The difference is calibration is a metrological procedure when we compare one device with the master device, which has then traceability to metrological standards which are which are kept somewhere or which are universally defined. And it is the operation is governed by ISO 17025. We have references, we have reference conditions, and so on. Verification is not metrological, but rather functional assessment of how the device is performing. There is no comparison with a master device per se, but there is an assessment on the functional side of how the device is performing. Let's look at the more specific parts. What is this assessment? On the next slide. It can be a self-monitored device, and more devices are coming to the market from different manufacturers, including where the device can self-monitor itself. So just checking itself, how am I doing? Am I okay? It is based on the international standards of monitoring, such as NAMUR standard NE 107. It is a compliant and traceable testing of the device, and it can lead further to condition-based maintenance. So that's how we go from monitoring the health of one device and then combining this data with the master data that we already have to build a condition-based monitoring program with the customer. And then we combine verification with calibration. So calibration, again, on the fixed intervals. Verification is more flexible. We don't have a fixed interval for verification. Verification can be done very frequently. In many cases with modern devices, verification can be done at the same time when the process is running. So there is no interruption with the process. That's different with the calibration. Calibration would involve disconnecting from the loop. And if it is a laboratory calibration, you have to send the device for the calibration to a laboratory. But in the case of verification, it can be done in parallel with the existing process. So in that case, probably one more slide, which will illustrate the difference. You saw already this first blue line is what it was with the device which was only calibrated at a fixed interval of 6 months. The orange line shows an instrument where you combine calibration, where it is extended. Calibration interval can be extended, but it is combined with a frequent verification, actually bi-monthly. So once per 2 months, the device is additionally verified. This combination is generating 80% of maintenance cost, while at the same time achieving significantly higher confidence level than the first device when you only calibrate per fixed interval, despite the fact that the calibration interval for the first instrument is shorter. So to conclude, while you usually have a fixed calibration interval for your critical instrumentation, this can be, first of all, periodically reviewed. Second, it can be based not only on the existing standards and manufacturer's recommendations, but on your master data coming from that instrument that will affect your calibration interval. So it can be individualized and it can be made more dynamic. And next, if dynamic and frequent changes of the calibration interval are difficult, then we recommend calibration plus verification combination, which can be developed again based on the existing data coming from the instruments, existing master data, and tailored to specific needs of that specific measurement point or a specific process. Now back to Adrian.
All right, thanks, Serhii. Thank you for that. Yeah, so you have seen in the beginning, like, okay, master data, right? What do I have in my plan? And now what we are doing with that is to have a criticality assessment, maintainability assessment, right? And from there, we are going into the optimization of the calibration and verification of the devices to improve your maintenance efficiency, right? And I would like to bring it back now on a way to say, like, okay, let's jump it on a digitalization journey, right? And I would like to give you a quick example on how this could look like. All right, so this is how a digitalization journey could look like. Beginning what we had in the first chapter, and then also what Serhii presented. So the first step is always the transparency, right? So as we explained in the beginning, master data and this dynamic install base analysis brings you the transparency in your plan, that you have everything, whatever you need, and you have it in a digital way, and it's not in folders, and you can analyze these data easily. If this is done, the next step would be to add documentation to all your assets you have in your plant. That includes service reports, calibration certificates, verification reports, and so on and so on. Especially in life science, compliance and traceability is a very important topic, right? And as Serhii just said, whenever there is a verification, whenever there is a calibration, right, to save this in a digital way where you can have it, access it from everywhere at any time, and to show it to your auditor or to the authorities or whatever easily, makes your life so much easier instead of looking in all these folders to see and find the right asset, right? So when you have those two already, let's say in a digital way, I have all my instruments, I have all my documents, then you can go and think even further, right? To say like, okay, what is when I see and I go into this preventive maintenance, that means condition-based maintenance. So I see all the history of my health status changes, right, of the devices. I see what is the N107 status. Also this verification, I can start from, let's say, a digital point or from a cloud environment. So I do not need to go even into the field to do the verification. Of course, calibration, yeah, as Serhii said, you need to put it out of the process. But when we think about verification to extend this calibration interval, how nice it is when you can just do the verification from your desktop or even from home, when we're all sitting from home now, especially now here in Singapore, and you get the result and you know everything is fine, right? And you do it in 2 weeks again, and the effort is like 2 clicks, which takes you maybe 5 minutes. Yeah? And then by increasing this calibration interval, you can really increase your maintenance efficiency. You can also, of course, think of digitalizing your process monitoring. Of course, most of you do have a DCS system already in place. But for example, for let's say utilities areas or remote areas, you can set these alarms and trendings and monitoring of values, or for example, energy monitoring, that can really then also bring you in the next step into this digitalization journey. This is all possible, of course, to have it in the manufacturer's, let's say, system or cloud environment. But there are also possibilities that you as a customer, you have already your system in place, for example, SAP or Microsoft Azure or Salesforce or whatever. And you want to have these master data information in your own platform, right? And therefore, there is, of course, also the possibility that all these information will be sent to your platform and you just consume the data and there's nothing else for you to do. So you have your one and only system, and you do not have one system for you and one system from manufacturer A and one system from manufacturer B and one system from manufacturer C. So this is also one step in the digitalization journey. We can go, let's say, together to identify, okay, this is the system I want to have. Please bring it all the data into the system so I can use it there. And if everything fails and there is not much knowledge and everything is like, oh, I don't know how it works, there is now, with this digitalization, of course, also the possibility that there is expert support from the manufacturers without being on site, right? So they have an insight into, let's say, what was the last health status. You can do screen sharing, video sharing, and especially now in COVID times, which are still we are, But also if you have factories far away and the manufacturer is not available, this kind of remote support is really also helping you to increase your maintenance efficiency. So just to summarize it quickly, so when you think about a digitalization adoption of what we just explained, is the first topic I already said, right? We are talking about reliability, comprehensive install base to mitigate risks. So this is all about master data, install base analysis. What do I have in my field? But then we're also going into the direction of workflow efficiency, right? How agile am I? How much field personnel do I need to really go into the site? And is everything paperless, reliable, and do I have a simplified process? That's what I just described with when there is a calibration, when there is a verification, when there is a service report, these documents will be automatically uploaded to a central location, and you do not need to send it via mail somewhere, print it out, put it in a folder, and all these kind of things, right? You simplify your processes, your workflow efficiency, so you can really take time for the more important things, maybe thinking about, okay, what is the best calibration interval or optimized calibration interval for my devices. And of course, if you think also about these instrument health monitoring, to have this overview and history of the NM107 status always available, and I get a notification when there is a failure, when there is an out of spec, when there is a maintenance require of one of my devices, you can increase your planned uptime, right? So everything plays together: calibration, verification, master data, process data, process monitoring, and this really helps you to bring your plan up to the next level. Last slide, and then we are open for Q&A. So what are the stages of such a, let's say, smart factory, right? So most of you already have automation. There's a DCS system in place. You see everything in there. But then to come to the point for predictive maintenance, for adaptability, there need to be more, right? So there need to be a part of the connectivity and the visibility to what do I have on my plant, right? Transparency, what's happening, and to understand and see what do I have. And based on that, as Serhii explained, we can define the criticality, we can look into the maintainability and give recommendations on how you can improve your calibration intervals. And step by step, you are putting your plant and your factory up to the next level. It's not something which is happening like this, right? And you say like, okay, I want to do that now. Please be ready in 2 weeks, right? That's a journey, right? That's why it's also called Digitalization Journey and also calibration interval journey. It's something which takes time, but in the end is worth the time and the effort because you will feel it afterwards. All right, I guess we're quite good in time. So there are still 10 minutes left for Q&A. So first of all, thank you all for your attention. Thank you for joining. Thank you also for the possibility to give you this insight on how digitalization and services can improve your maintenance efficiency. We hope you enjoyed it. And yeah, we are now open for questions via, you can just open your mic or even in the chat. I can quickly check the chat. So there was one comment from Nathan Tan saying like the document lifecycle should also determine the periodic review performed, which means the equipment should be assessed during the review.
I can comment on that. It is so. The asset of the equipment is a periodical thing, and it's natural there is a period for assessment of the equipment. What we're trying with Adrian say here and emphasize is that normally or quite customary, when an equipment is assessed, it is the present state of the equipment is being assessed. That's a traditional way. Say, I represent a service organization. So I send field service engineer to the site and they go, they see the equipment, they check the current health condition, and they deliver a report. And that becomes the ground of considering what is the next action, is there any action needed, and so on. What we're trying to change and to advise our customers, and the way we actually ourselves operate, is to analyze the data coming from the birth of that instrument to the present state of the instruments, the whole timeline, the whole history of the instrument, because the instruments are smart. They are producing enormous amount of data. If we're able to capture it, put in the system, and we have that system that analyzes the life of that instrument, we're coming closer to prediction what will happen after 6 months, after a year, after 2 years, and so on. And that should become the basis of the optimal maintenance program, optimal calibration program. So we're already putting a step into the predictive ability of our service operations. That is the difference, and that is the way, the path to the future, which is not so distant.
Absolutely, absolutely. Thanks, Serhii. Maybe also just one thing to mention is like, I guess we all have this digitalization, IoT, Industry 4.0, all these buzzwords, but we need to understand that it's not just this, right? It's always a combination of what we have currently, right? As for example, these services, and the digitalization improves your processes, right? And that's important to understand, that you not just say, okay, I digitalize because it's the trend. There need to be a value and there need to be a change in process, right? Which help, and where digitalization is a tool to improve it, right? And we do not use digitalization just to use digitalization. That's sometimes always the wrong understanding, but I guess we made it quite clear.
How do you see the future about cybersecurity when we talk about remote access rights, Salvador Montilla? What do you think, Adrian?
Yeah, definitely. So cybersecurity will be always in topic, right? Luckily, there are certifications, there are agencies which make sure that whoever offers cloud security or cloud services, that they comply to the latest and highest technical standards, right? And if you follow these kind of certificates and you have this as a company and you can show it to customers, then there's the time where they can say, okay, we can trust you. Of course, it always develops, right? So it is not standing still. And also all these certificates, they develop, right? And you always need to be up to date. It is a critical concern, but to be competitive in future, I guess there is also no way to think about digitalization, right? Because it really helps to make sure that you run your plant smoothly. It is always critical. There are a lot of assessments. We had customers where we talked about this for 6 months until they approved it, right? So that's not something which happens also overnight. But when they are working together and okay, this is a gap and this is a gap, yeah, then there are things which can be closed, right? Or which need to be delayed to a later phase. But it's just an open point we can discuss. But just saying, oh no, because we have issues with cybersecurity is not the right thing, right? We should openly discuss that on the digitalization part, because there's always a kind of a solution. And yeah, as I said, with these certificates, normally you're always on the safe side if manufacturers have them. All right, Serhii, there's another question from Cherry. Third-party calibration becomes a challenge during pandemic. Can self-calibration using available information count, except that there is no calibration certificate?
Well, it depends on the requirements, and it depends on the what kind of device are we talking about? What is the criticality of that device? Again, we're coming to the criticality. Third-party calibration, yes, but nevertheless, I work with a lot of customers and we do calibrations for the customers. It's a challenge, but there are many ways to calibrate. We go to the customers, we perform on-site calibration, we take the laboratory calibration, and as I said, self-calibration, by the way, is a new trend. Self-calibrating devices are already there in the market. It is possible to use self-calibrating devices, but they are not, how should I put it? They are the international system of traceability and so on. It's not complete to apply for the self-calibration devices. In all practical terms, if you are sure that self-calibrating works for you and that doesn't create a problem with any legal issues, then of course we recommend. But if still you need a calibration certificate, you need to go to calibrate the devices. The process of self-calibration is slightly different from the regular calibration. In the regular calibration, you do the comparison between the two devices. In the self-calibration, there is no comparison like this, so this is like an emulation in a bit. So it will take some time to have an internationally recognized system for approvals of these self-calibrating devices. But nevertheless, in the cases when it is you have a trust in this technology, it's a trustable technology, and there is not an issue with compliance, we can go and work with the self-calibrating devices. One example of that would be thermometers, for example. We have already good examples of the temperature meters which are self-calibrating. Less with more complicated devices, for example, like flow meters. They still require a comparison way of calibrating.
I guess there's just coming another question in there.
Yeah.
What are examples of self-calibrating devices? I guess you just mentioned one with the temperature device.
Temperature.
We have Endress+Hauser. But do you think it really replaces the usual offline calibration in future, or do you think it's just something also intermediate, similar to a verification, but let's say more concrete?
Again, it depends on the measurement point and depends on the specific device. I would hardly imagine that we're ready to replace that, for example, for flow calibration. But for the temperature calibration, when we have many devices, which are like, it's a different range. We have multiple of temperature points, and it's really difficult to go and physically calibrate these devices. And these devices are so small and quite often so cheap that instead of fixing that device, you just go out and replace them. So if you consider all these factors, then yes, it wouldn't make sense to calibrate all of them in a manual way, in the comparison way, and so on. Self-calibrating is the future technology for those devices. While for other devices, which are really critical, which are really big, which are the focal point, and the criticality is high, then it is still best to have them completely conformant to the international traditional way of calibration. At least this is how it looks in the moment. We will see how it will change in 10 years.
Yeah. Okay, there was a follow-up question from Jerry that can we verify the current self-calibration result against past year trend?
Can we verify the current self-calibration result against the past year trend? Yes, but we have to be careful about the word, what is verifying against the trend.
I guess it also depends on the device itself. Huh?
Yeah. Because trends can be tricky. I have many examples when the customers see the trends like based on the past 2-3 points, and then they say, oh, the device will, they draw a straight line and the device will go out of tolerance pretty soon. So they start to do the adjustment. Well, it's too early. Adjustment can actually bring the wrong results to the whole idea of calibration. So trends are not linear. Trends are complicated, and that is why we take a lot of factors when we do the prediction. So it's not only the current trend, it's the age of the device, it's the conditions where the device is used, because these curves we'll see in practice, they're very, very different in all possible situations.
All right. Thanks, Serhii. I'm just looking at the time. I guess we are at the end of the session. Thank you all for the questions. I would just highlight that if you want to have more information and more questions, you can reach out to us. The slides will be shared with you in a PDF, as far as I understood. So you can reach out to Serhii or to myself. And then, of course, we can also continue this discussion. Thank you all for joining. Thank you, Serhii, for being here with me, and also thank you to the ISPE team to give us the opportunity. And I hope it was insightful for you, and we're looking forward also to hear you in the future.
Thank you, Adrian. Thank you very much to all of the participants, to all the listeners, and to the organizers.
All right. Thank you, and then enjoy the rest of your evening.